Hello. I promised I will go over piecewise functions for you so that you can check them out and study them at home again. So I hope this helps. Functions can be represented by a combination of functions, each corresponding to a part of the domain. These functions are called piecewise. So again, this is a combination of functions, two or more. In this case, function fx is combination of two different functions. It's a function equal to x plus 3 on a certain part of the domain and 2x plus 1 on the other part of the domain. This is called constraints. In other words, this is how we divide the domain. These are the different parts of the domain. And the first expressions, they tell me how to calculate the output. How we calculate the output. So let us try to fill this table. We have gotten x, 3, x is 7, and x is 5. It's our job now to decide which equation to use. Is it going to be x plus 3 or 2x plus 1? And then explain why. So x is 3. Let us check the constraints and I misspelled it. Okay, let us check the constraints and see which function we will be using. 3 is less than 5. 3 is less than 5. And you see that here. So we'll be using the corresponding function, x plus 3, corresponding equation. 7. 7 is greater or equal to 5, as you see in the other part of the constraints. So that's why we'll be using the corresponding equation. That's 2x plus 1. And then finally, for 5, because 5 is greater or equal to 5, we will be also using 2x plus 1. Now, we will substitute in value for x and solve. So this is the equation we are using for 3, x plus 3. If we put 3 instead of x, we get 3 plus 3, and the value is going to be 6. For 7, we're going to be using 2x plus 1, which is 2 times 7 plus 1, and that's 15. And then for number 5, we will be using 2x plus 1, which means 2 times 5 plus 1, and that's 11. So we are done with this page. I hope this all makes sense, and we'll be looking at graphs next. Again, in example 4, this piecewise function is again a combination of two different functions. First, we will be looking at our constraints, and I decided I will highlight it for you. I hope this helps at least a little bit. So when we are talking about the first function, it's going to be for x less than or equal to 0. Where are those x? It's here. And that's when we are going to be using function or equation y or fx is minus 2x. On the other side, we will be using, on the other side, x is greater than 0. We will be using the function 1/2 of x is, I hope you like my colors. Okay, we'll be using 1/2 of x minus 1. Let me now use black and try to do really thin line just so that I can graph, and then later I will trace only the parts that truly are part of this function f. So we are talking about two lines. One of them has an equation y is negative 2x. I know that basically that means that there is plus 0, which is my y-intercept right here. And then negative 2, it means 2 up and to the left. Okay, so this is my line. Let me do minus 2 and over 1. So let me do this as a dashed line. And later I will be only tracing the part that is truly a part of this piecewise function. So this is my first line, minus 2x. Okay, now where is this truly part of our function f? On the yellow part. And is the 0 included here? It is. So we will trace this part. This is true. Function f is minus 2x for all the x's that are less than or equal to 0. And then the other line. The y-intercept is negative 1. That's right here. And slope is 1 over 2. So we go 1 up and 2 to the right. This is our second line. Of course, it does go to the left, but that part is not part of the function f as it is defined here. Because only on the orange, for all the x's that are greater than 0, so we will trace it here. And remember, x0 is not part of that. You see the symbol greater than, so I have to make the empty circle here. So this is the graph for this function right here. I hope this all makes sense. Now function fx in example 5 will have 5 different segments. And we can graph them. One of them, fx is gonna be minus 1. So it's gonna be here.